what we've done so far, we are arriving at the same level as what we've been doing in software 1. Okay? And now we're going to look at new concepts that we haven't seen before. And today especially, we're going to look at the new one, which is inheritance. What is inheritance? Something I can do as well in Python. But here I'm going to focus only in Java. If you want to know more how to do that in Python, just have a reference to a book, and then you will see how it's going to be done. But the concepts are going to be relatively similar, and there will be some differences, and I may mention them later on during the course. But for what we're going to look at today, we're going to look at a simple inheritance. What does it mean? Why do we want to do that? And what are the different impacts on this? I will not have time to go over all the things about inheritance yet. I will continue next week, where I'm going to look at polymorphism. So something you may want to look at in advance if you want to. But here I'm going to do the lecture about inheritance, and hopefully I've got a bit of time to make an example. So I will have implemented a class rectangle, and then I want to create another class called square, which is going to inherit from the class rectangle. What does it involve, and why do I want to do that? So first we're going to have a little introduction. One of the problems we've got is when we create a design for software, sometimes we have to use many classes with the same similarity. And one thing we want to do as much as possible is to reuse what we've done so far, not to rewrite the same thing. So we can try to take advantages of the similarities to reduce the amount of code rewrite. And if we reduce the amount of code rewrite, we're going to reduce the number of tests we need to do. So we're going to be more performant and more resilient to change as well. So it's very important for us to look at what kind of tool we can have. And in object-oriented programming, one of the tools is inheritance. So that's another fundamental object-oriented technique, something we need to use. So what we're going to have is a kind of a base class, who's going to have many implementations already done in place. So here in my case, I want you to look at, for example, later on at the end of the lecture, I've already created a class rectangle. So that's my base class. And then I'm going to use that as a starting point. So we simply state which class you want to use as a base in order to inherit its member. And when I say inherit its member, I'm talking about the state as well as the method. So I should inherit the behavior as well as the current state of the object too. So when I'm going to design that, if I've got a series of classes already in place, what I may want to look at is what are the commonalities? And if they've got commonalities, can I regroup that into something a bit more general rather than something already very detailed? That's going to be a bottom-up approach. I've got plenty of classes, and I want to try to regroup them together with the same concept, if they've got a lot of similarities. So as you can guess, between a square and a rectangle, there is a lot of similarities here. Okay? So if I started with a class rectangle and a class square, what can I do to make them as something quite similar? They've got similarities. What kind of abstraction I can get from it? Or what I've got is something very general, a shape, and then a shape is too general for me. I may want to try to have smaller shape, something where I can use it. For example, if I'm looking at a shape in general, I don't know to compute the area of that shape. But if you gave me something which is more specialized, like a square, I will be able to compute the area of a square. Okay? But to have a formula to compute all type of area depending on the shape is not possible. Okay? So I may want to try to specialize that a bit more. That's going to be a top-down approach for designing my program. So the more generalized it is, the higher it's going to be in a kind of a hierarchy. And we call that the superclass. And there is other term we can use. We can call that the parent class or the base class. Okay? They are the same thing. They are synonyms. So that's the one at the top of my hierarchy. And when I start to specialize a bit more, I'm going to have subclasses or child classes that are derived classes. That synonym, meaning I'm going to use what I've got in the more general classes, and I'm going to specialize a little bit more. In my case, the superclass will be the rectangle, the subclasses will be the square. Yeah? The parent will be a rectangle, the child will be a square. So, as the name implies, the child inherits characteristics of the parents. Okay? So you agree that a square is much more specialized than a rectangle. It's a rectangle plus an additional condition. All the sides are of the same size, which is not the case for a rectangle. So this slide is very important for you. Okay, if you've never done object-oriented programming, this slide is essential. If you're unsure if there is a kind of inheritance hierarchy here, when you look at a class, you just have to use the is-a relationship. So when I'm going to look, for example, at a rectangle and a square, I can say that a square is a rectangle. What I cannot say is that a rectangle is a square, because there is some example of rectangle which are not square. You agree? So if I've got a relation, if I can say in plain English, something is something else, that first one will be a subclass, could be a subclass of the last one. Does that make sense? The as a relationship has nothing to do with inheritance. We call that composition. So if I'm looking at a car, and I'm looking at a wheel, I cannot say that a wheel is a car, or a car is a wheel. I cannot say that. You agree? What I can say, though, is a car has wheel. So a car is going to be composed of 4 wheels. You agree? Mostly, depending on the car. Yeah? So here that's composition. That means that class car will have attribute of the type wheel. So it's composition. It's not an inheritance. So there is no characteristic from a wheel that can inherit from a car, for example. You agree? So if you are unsure, just say it in plain English. Is my superclass, is my subclass, is a superclass. Whatever you want to put in subclass, or whatever you want to put in superclass. That makes sense? So if I'm looking at a circle, I will not be able to say that a circle is a square, or a square is a circle. So there is no relation in inheritance. However, what I will be able to say is a circle is a shape. A square is a shape. So both of them have a common ancestor, a common parent, the class shape, which is more general. You agree? So there will be inheritance between the shape on the circle and between the shape on the square. Yeah? Is that clear for everybody? Any questions so far? So remember that slide is very important. It's going to help you to design a class later on, and especially inheritance. So here are some examples of inheritance. So when I've got student, I can have graduate student or undergraduate student. If I'm looking at shape, I can have circle, triangle, rectangle, or more than that eventually. If I'm looking at loan, I can have a car loan, mortgage, and improvement. I can look at employee, like faculty and staff, and I can look at bank account, whatever. Okay, depending on the problem, you may have that type of relation. Okay? There are simple examples of inheritance. So, to tell a derived class, the programmer can add new variable or method, or can modify the inherited one. Okay? So, for example, when I'm going to have a rectangle on a square, one thing I may want to change in the square method is the toString method. Because probably the toString method of rectangle will print something like I'm a rectangle, whereas the square method wants to print I'm a square. Okay, so I may want to rewrite that. Yeah? When I'm going to look at, for example, get area, to compute the area of a rectangle or to compute the area of a square, they are the same formula, depending on how I'm going to store the square thing. Yeah? For example, if I'm looking at the center position of my square, it will be the same as the center position of a rectangle. So when I'm going to design a square or a rectangle, I may want to have the center position as an attribute, xy, for example, and then I'm going to have the width and the length for the rectangle, and I need only one, for example, for the square. Then I will have to decide, do I need to create a new attribute for the square, or can I use the one from the parent? Okay, that's something I will think of when I'm going to implement that. You agree? But they can share commonalities. the width and the length may be the same thing. Or I can have a different parameter called size, for example. But I will have the same attribute for the x and y position of the center of the object. So here, software reuse is at the heart of inheritance. So if I can avoid to rewrite a method, I will use the one written in the parent class. Yeah? If I need something more specialized, in that case I need to rewrite something more. Or I may have to rewrite what is existing already. And I will have a specific term for that. So when I'm looking at inheritance here, especially in Java, in other languages that's not the case. For example, Python or C++ is not the case. But in Java, it's going to be a tree-like data structure. In that case, each class is going to become a superclass and/or a subclass. So two children of the same parent are called siblings. So for example, I had circle, rectangle, which were siblings because they were subclasses of the class shape, for example. Okay? So they inherit from the same parent. So when I'm going to look at that, if I'm doing a bottom-up, I will have to look at the commonalities between the circle and the rectangle to find what should be in the superclass. And here one which is obvious is to put the central position of my object. What I cannot put in the superclass is the length. Because for a circle it's going to be a radius. For a rectangle I will need to measure, one for the length and one for the width. So that should stay in the subclasses. Okay? In the specialized classes, not in the superclasses. But the position x, y of the center of the object can be put in the superclass shape. Does that make sense? Yeah? And when I'm going to look at an attribute or a method from the superclass, all down the hierarchy is going to be given to the subclasses. Okay? So the first child, the grandchild, and so on and so on. Okay? Will share the same attributes. So a child class inherited from all of its ancestor class. When you look at a problem, you need to keep in mind there is no single class hierarchy that is appropriate for all situations. Okay, so depending on your problem, you may have a different type of hierarchy. So here is an example. Community member. So I'm going to look at, for example, the University of York. What I will have is the employee, the student, and the alumnus. That's the first level of inheritance. Then I'm going to have the faculty, which is a subclass of an employee. And it's going to share the same attribute as the one I've got in the community member. So for example, the community member can have a name and an address. The employee will have a name and an address. The faculty member will have a name and an address. And the administrator will have a name and an address as well. So they inherit everything from the community member. Yeah? An employee will have a salary. So if I'm looking at staff and faculty, they will have a salary. If I'm looking at teachers, they will have a salary. But if I'm looking at students, sorry, you don't. Okay? So that's the idea we're going to share here. And in the community member, I'm going to put everything which is related to all of them. Yes?
If you want to recommend that the administration and staff share column, how would you do that?
So if they've got something in common between...
Administration and staff.
Yeah.
Not teacher.
So here when I'm going to have administrator and staff, in my design, that means there is some attributes which are specific for faculty. A faculty member may be an administrator for something specific. Okay, for example, an administrator for the ethics committee, or an administrator for the board of examiner or something like that. Something which is not done by the admin staff. That makes sense? So they've got a specific role, that's why they are inherited from faculty, which is different to the other staff who does not inherit from faculty. Does that answer your question? So here is very abstract design. So let's try to look at the other one in that case. When you are going to look at this one, okay? When I'm looking at a shape, it can be either a 2D shape or it can be a 3D shape. And if I'm looking at a 2D shape, I can have circle, square, and triangle, or I can have, if I'm looking at a 3D, sphere, cube, and tetrahedron. Yeah? That makes sense? So when I'm going to make my design, I need to decide what is common between 3D shape and 2D shapes. Yeah? For example, it can be the color, if there is a color of that object or something like that. So when I want to implement that in Java, there is a new keyword I need to learn. It's called extend. So here I've got my parent class, which is shape2d, over here. That's my parent class. And here I'm saying that the class circle extends the class shape2d. That means that circle is a child class, a subclass of shape2d. So any attribute and method I've got in shape2d are going to be part of circle. Yeah? Although the private method, I will not be able to access them in the class circle. Because private is only for the class shape2d, if they are in the shape2d. Okay? So when you've got a private method, it can only be accessed from that class. Okay? So we'll have to learn a new term next week about how we can do that between subclasses. But here, just to be able to share all the public method and all the public attributes, I just have to use extends. Is that clear? Yeah? So we had the this reference when we created a class. How can I reference the superclass? Guess what? I'm going to use the keyword super, which is the same thing as what we use in Python actually. I use the keyword super if I wanted to reference the superclass. So what is a super reference? It's to be able to reference the superclass. So for example, if I want to be able to reference the constructor from the superclass, because it can do part of the construction of my object, I may want to use the keyword super. Or if I want to use a method from the superclass, I can use the keyword super as well. So constructors are not inherited even though they have a public visibility. So one thing I will have to do when I inherit a class is to create the constructor for that class. Even if there are some which already exist in the superclass, I will not be able to use them. Okay? So I will have to create my own constructor for that subclass. Whatever. So the only case where it's not completely true is when I don't define any constructor in the superclass. So there will be a default constructor. Therefore, I will have a default constructor in my subclass. But if, as soon as I define a constructor in the superclass, the subclass will have to define a constructor too. So quite often, we may want to use a constructor for the superclass to be able to start to build the object, and then we are going to add a few things on top of it. So for example, when I'm going to have a shape, I may want to have the constructor who's going to take two parameters, the x and y, for the position of the center. But when I'm going to look at the circle, I need to add something else, the radius. When I'm going to look at rectangle, I need to add something else, the width and the length. So I will have additional parameter in the constructor. But to set up the x and y, I may want to use the one for the superclass. It's very important if the code for the superclass is very complicated. I don't want to rewrite it if I know it works in the superclass. Okay? I agree. To set the x and y, that's something I can rewrite if I wanted to. But in principle, always think that the example I gave you is much more complicated than what it is really. So the code is much more difficult to write for the superclass constructor. And I want to reuse that. A child constructor is responsible for calling the parent constructor. And what I need to do here, when I'm going to call that parent constructor, I'm going to use the keyword super, and then the list of parameters corresponding to the parameter of the constructor from the superclass. And when I'm going to do that, that needs to be my first statement in my constructor for the subclass. It cannot be anywhere else than the first statement in that constructor. So I'm going to provide an example later on during the lecture, during the live demo. So the super reference can also be used to reference other variable and method defined in the parent class. A child class can override the definition of an inherited method in favor of its own. For example, when I've got the toString method for a rectangle, I may want to override the toString method to write my own definition for the square. Yeah? So overriding is not the same thing as overloading. Okay, I'm going to go back to that. But if I'm overriding, I need to have exactly the same signature as the one from the superclass. Otherwise, it's going to believe it's a new method. Okay? So remember what we said about signature on overloading. For overriding, they need to have the same signature to override it. Okay? The type of the object executing the method determines which version of the method is invoked. That's going to be polymorphism. Well, something we're going to look at next week. Okay? I want to make sure you understand everything we do about extending a class, and then we're going to look at polymorphism, which derive from the hierarchy of my class system. A parent method can be invoked explicitly using the super reference. Okay? That's very important if I override that method. So I will be able to call the one from the parent class using the super in front of it. If a method is declared with the final modifier in front of it, it cannot be overridden. Okay? So it is not really like a constant, but almost. So here I'm saying the subclasses are not allowed to override that method. That's the final version of the method. Okay? In that case, I will have to use the keyword final in front of it. The concept of overriding can be applied to data and is called shadowing variable. Do not do that. Okay? That's bad practice. It's going to make things much more confusing. So for example, if I'm using in my class rectangle x and y, and I put them private, I will not be able to access x and y directly in the subclass. Don't rewrite the attribute x and y in your class square. You are allowed to do that. Don't do it. Okay? It's very important not to hide or shadow a variable. It's going to make your code much more difficult to maintain. So it should be avoided at all costs. So, what I said before, don't confuse the concept of overloading with overriding. There are two different concepts. Okay? So overloading deals with multiple methods with the same name in the same class but different signature. Overriding, they've got the same signature and compare with the superclasses. Okay? The object class. In fact, we've done something already with inheritance without knowing it on Friday. With the vector class. I ask you to rewrite the method toString and the method equals. In fact, they are methods from the class object. An object is at the top of all my class hierarchy. Everything from the Java classes are inherited from object. Okay? We didn't know that, but by default, if it doesn't extend anything, it extends the class object implicitly. Okay? It doesn't need to be explicit. Yeah? Sorry, wrong button. So a class called object is defined in the Java package of the standard library. All classes are derived from the object class. If a class is not explicitly the child of another one, it's going to be a child of object. So object class is the ultimate root of all the class hierarchy. So what is important here? The object class contains already some useful method in place. In fact, equals and the toString are method already defined in the class object. But there is more. Okay? That's why I ask you to override these two methods. So the one we're going to be interested here to override are going to be the equals method, just to check that two objects are equals. And the hash code is something we're going to address later on, but you need to have a little bit more theory before we address that. And then the toString method to be able to have a string representation. Yeah?
To override toString, do we have to return a string or have a
Yeah, it needs to be exactly the same thing. Okay? Same signature, need to return this, need to have the same modifier, and need to return the same value. Okay? And same parameter, same name. Exactly the same thing. Yeah? Hash code is something which is very useful, but we're going to see that later on. Okay? We need to go through the theory first with Dimitar. Notify all, wait, and so on. That's something you may want to look at later on, and probably something you will have to address next year in your engineering project. So here, the one I want to focus on is the equals and the toString method. So when I've got the class point, for example, when I'm going to define it, by default, it's going to inherit from the class object. So all the methods I've got here are part of the class point, but I don't have to override them. What I may want to do is to override the equals method and the toString method. So let's have a look at the different method here, especially the equals one. If I'm using equal in Java, it's going to check the reference address. It's going to return true if they are the same reference address, meaning exactly the same object. But that's not what I want to do. When I'm looking at 2 points, I want to say they are equal if they've got the same value x and the same value y. You agree? Not necessarily the same value in memory address. So that's very important for me to be able to check that. So I may want to override them. So let's look at what's happening here. So when I'm going to do p1 equal new 0.53 and p2 equal new 0.53, in theory, in my mind, p1 and p2 are equal. But if I'm doing p3 equal p2, again, they should be equal. Let's see what's going to happen when I'm going to make the statement over here. That's what I have done so far. Here I created the point p1 and its reference to 53 in a memory address. Then I've created p2 and it's going to reference another memory address with the value 53 as well. And then I say that p3 is equal to p2, so both of them are going to point to the same memory address. You agree? Okay, something we've done before in Python on the same principle in Java. Now if I'm trying to do p1 equal p2, the value I'm going to get is false, because you're going to check the address, and they are not at the same address. When I'm going to look at p1 equal p3, it's going to be false as well, because they are not pointing to the same address. And finally, if I'm doing p2 equal p3, it's going to return true because they are referencing the same object. Is that clear so far? Any question? No? So using equal is not the way to go to check equality between objects. So what I'm going to do instead is to look at the equals method. I didn't do that just for the sake of it, it's because I know it's something very important to do. That's why you have to override these two methods in the vector class you've done on Friday. So when I'm looking at the method equals for the object class, it's very simple. What it returns is this equal O. They are checking if it's the same reference address. So that method equals already exists in whatever class I'm going to construct, because it's given by the method, the class object. But if I'm using that one, if I don't try to override it, I will not be able to check the proper equality. So for example, when you compare two strings, saying that string 1 dot equals string 2, it's going to return true if they've got the same characters in the string, not necessarily at the same address. You agree? So they did override that. So when I'm going to write a class, I may want to do the same thing. So for that, I need a new keyword, instance of. The instance of is going to test if a variable is an instance of the class type. Okay? And if that's the case, it's going to return true, and then I can do something. If they are not the same, it's going to return false. So if I define a variable p as a new point, and I try to say that p is an instance of point, that's going to return true. If I try p is an instance of string, it's going to return false, because a point is not a string here, it's a different type of object. If I'm saying that p is an instance of object, it's going to return true, because of the inheritance principle. What does that mean? I say that any class I'm creating, like a point, inherits automatically from the class object. So p is an object, because a point is an object due to the inheritance. You agree? Therefore, p is an instance of an object with more specialized things, but that's an object nonetheless. That makes sense? So in fact, it's going to look at the hierarchy. Yeah? On the inheritance. That's why P is an object. When I'm going to have a variable with the value null, it's going to return false all the time. Okay? Is that clear for everybody? Yeah? So, when I'm going to cast an object, we've done that with primitive, but casting an object is slightly different. In some way, when I'm looking at Clark Kent and Superman, Superman is a subclass of Clark Kent. And when you want to become Superman, you just have to remove his dressing of Clark Kent, and then he can fly. That's the same principle when I'm casting. We've got these guys on object, and depending on which costumes they're going to put on, they will have different behavior. That make sense? Kind of? So here, a point, because a point is an object, I can put that into an object variable. Okay? Because it is an object. Then what I can do here, a string is also an object. So I can put a string into an object variable. Yeah? When I'm looking at O1, and then I want to use the method translate from the point, for example, to be able to move it. An object doesn't have a translate method. So if I was doing O1.translate, it's going to tell me, what are you talking about? Yeah? I don't know the translate for an object. So what else should I do then? The first thing I'm going to say is transform O1 into a point and then use the method translate. The compiler will be happy with that. Okay? Even worse, what I could do is to say that O2 transform that into a point. The compiler will be fine. But at runtime, you will have an error. Because it's going to try to transform a string into a point, and it's going to say, no, no way. Yeah? So compiler happy, runtime not happy at all. So that's what we need to look at. So here I know that O1 is being based on a point, so I will be able to change it back into a point here. Because it's been built as a point, but stored into an object variable. So that one will be fine. Same thing with O2. Okay? Is that clear? So that's casting. And then we need the keyword instance of, and then casting to be able to write a proper equal method. So here, casting reference is different than casting primitive. Really casting an object reference into a point reference doesn't actually change the object. Okay? It just changes these guys. That's all. And it tells the compiler to assume that O1 refers to a point object. So I could do the same thing with O2, even though I know it's completely wrong. But the compiler will be happy because he assumes you know what you are doing. That's a big assumption, especially when I'm coding. Okay? But the compiler will be happy with that. So when I want to write the class, the method equals, I need to have object as parameter, nothing else. Whatever the class I'm going to write, if I want to override the method equals, I need to pass an object as parameter, nothing else. That's why in the practical on Friday, for the class vector, you had to use the equals with object and not vector as parameter. Yeah? So in my class point, the first thing I need to do is to check if O is an instance of point before I can do anything. You agree? If I pass a string here, it's going to say no, it's not, and I can return false because I will have no equality. But if it's true over here, then what I will be able to do is to cast O into a point, store that into a variable called over, for example, and then I can check that the X and the Y are the same, and if that's the case, I return true. If it's not, I return false. Is that clear for everybody? Yeah? Okay? So we are saying it here. I've done a bit of polymorphism. So I'm going to look at that a bit more in details next week. But here, without knowing it, I've done a bit of polymorphism because the variable P could have two different views of it. So here, how can I use the class object? I can store a variable into an object by using a different constructor. Okay? I can pass a variable as an object. And then if I know to cast it, I will cast it, like in the equal method. I say that an array could not have different type in the array. It's kind of true. But here, I can create an array of objects and put whatever I want in that array. Not a good idea, but I can. So I do. But the idea here is later on, when I want to use that, I will have to try to find what is the type of each object before I can do anything, which is not very friendly. You agree? But nonetheless, what I will be able to do is to have an array of objects and put whatever I want into it. Same thing with an array list, where I can put any object into it and I can mix match the different type. Because everything is an object. Yeah?
It probably does initialize with null, doesn't it?
Yeah. All of them are going to initialize as null.
So then you create an array of objects, but if you prove or check every single object in there, it returns false if it was just initialized.
So what's going to happen when I'm going to put a string and then I'm going to put a point in my array of objects? If I try to say that, give me the length of a point, it's not going to be happy about that. If I try to translate a string, it's not going to be happy about that. So every time I'm looking at object at position 0, I need to check what kind of object I've got here, what kind of method I can use. Not very friendly. And we're going to see that a bit more when you look at collection, what we should do.